going to put the word recall here because in theory you maybe learned it once upon a time somewhere else, but the production possibilities frontier. Now I think we did go over it with Jen and Tom on the island. Didn't we do Jen and Tom first day of class or so? Talked about Tom on the island. Looks something like this, maybe. I think I might have talked about it, but the production possibilities frontier. What was? Let me see that. What did I give you guys? Remember, you got the abbreviated version. I think we maybe just talked about it. Okay. So the production possibilities frontier shows the maximum combination of two goods an economy can produce, given its available resources and technology. So if we add up all of the resources on our island today, land, labor, capital, entrepreneurship, how much stuff could we make? With this economic model, we just look at two goods. Maybe we've got weapons of mass destruction. So WMD, we need some of those to kill the bad guys and protect our country. Weapons of mass destruction. And then we need some food to eat sometimes too. So given our limited resources in the nation, what should we make? How many nuclear weapons should we have in our arsenal? How many guns? How many automatic weapons? And then how much bread should we have? How much rice and beans? How much McDonald's cheeseburgers? How much food, right? Choices, choices. If I want more weapons, if we're efficient, if we're operating efficiently in the economy, and we're at this point right here, point A, where we've got 100,000 units of food, and we've got 46 units of weapons of mass destruction. That's one possible combination. How do I know if that point is efficient? What makes that point efficient from society's use of the scarce resources of land, labor, capital, and entrepreneurship? That's one combination of weapons and food. What makes it efficient?
Maximize all the resources.
Okay, if it maximizes all the resources, yes. That might be one way. We could be using up all of the resources and not necessarily using them efficiently, though, right? Opportunity cost. So what do you mean? I think.
So it's like they're each giving up the least amount to get the most?
Yes, and so how could we test whether this point is efficient or not? How could we kind of test it? Draw the frontier. Now, what if we don't have the frontier? That's a good thinking, right? So you guys hopefully maybe got this idea that there's some sort of frontier out here. How would we know for sure that this point is efficient? And I think Katie's onto something by thinking about opportunity costs and maybe doing something. What do you think, Max?
Operating at their competitive advantage.
Okay, so how can we test that point? How would we know for sure?
You make any more food or weapons of mass destruction without giving up the other.
Very good. All right, can you make more of one good without giving up any of the other, right? So if you can move to a point like B or C or D, then A kind of sucks, because it says if you were doing better, you could have more of this good without giving up any of the other, right? So you could move to a superior point without sacrificing anything. So we know that point A is efficient if the only way we can get more weapons is to give up food. Now we start to see the power of choice here when we think about, well, I want to defend the nation, but I don't want people to go hungry. We got choices to make. Do I die by some Middle Eastern terrorist, or do I die by starvation? Choices, choices. We're always making choices, right? So if I feel like I need more weapons, and I really think the optimal level of weapons of mass destruction is 50, the only way I can get to that point is to give up some amount of food. So we're going to have less food, which maybe is good in the United States. We'd have less of an obesity problem, so maybe we're sitting a little fat with food anyway. And so maybe it's okay to do that. Now, this is strictly, I want to bring that up since we're talking about maybe I kind of inkled there on our liking of weapons or our liking of food. I really don't have that playing a role here. These are production possibilities. So tying back to what I started you on last time, this is the supply of all goods and services, which includes food and weapons. We can only have so much. And so this concept of the production possibilities frontier is similar to our potential level of GDP, real GDP in the economy. From a conceptual standpoint, there are limits to what we can have. And those limits are a quantity, a physical constraint rather than a dollar constraint, right? There's no dollars here. This is quantity of weapons, quantity of food. All right, so that production possibilities frontier concept now looks like this in our aggregate demand, aggregate supply space. Real GDP is the quantity of all goods and services produced within the nation's boundaries. And somewhere along this point, there's really a maximum potential. And that potential level of stuff is independent of prices. And this is the long-run aggregate supply curve. So long run, I guess I can do a little R if I'm use that notation. Long run aggregate supply. So long run aggregate supply shows the potential level of real GDP at full employment. So I'm sneaking in a new word on you. This is the first time I've introduced that. Full employment. As John pointed out, inside this frontier, let's see, I got a B, C, D, let's pick some sort of point here, E. We're not fully employing all of our resources. Either there's some unused labor, some unused capital, so we're not using things up, or maybe we're using it up, but we're not using all of the technology at our disposal, right? So technology sneaks into the picture too. What is technology? Technology is just information. It's just how you do stuff. It's how you work. It's how you communicate. If we're not using the technology at our disposal, then maybe we're using up all the resources, but in an inefficient way, so we're not on the edge of the frontier. Okay, so key thing here is that we're at full employment. And this then starts to set the picture of how we cannot be at full employment at different points in time. So in the short run, in a short period of time, we might have some adjustment going on to where we're not fully employing all of our resources. Okay, so questions on that at all? All right, so let's make sure we define clearly what's being measured on our axes. Which I just erased. So, price level. Katie, give me a number between. Oops, I need to do that. 6 and 10. 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Jake, you're up. Price level. What is the price level?
What is price level?
Yep. Give me a definition of what the price level. If Jake can't figure it out, we're going to go to you. So it is in your notes, I'm pretty sure, somewhere. So Jake, I'm kind of asking you, I'm putting you on the spot here, just without even looking at your notes. What's your gut feeling on price level? We're measuring it here. So I got all goods and services, and then this has something to do with prices. It had something to do with inflation. It was related to inflation.
Isn't it like the real GDP or the
Okay, good. You're jumping to the how we calculate it, right? So it was based off of a relationship between nominal GDP and real GDP is how we generated it. Okay, who wants to add on to that? Good. Who wants to add on? Max?
It's an average of all the prices?
Okay, it's an average of all prices in the economy. Good. Anybody else want to add on to that? Chelsea? Good, we had that base year concept, right? So what we were trying to do is see how prices are changing over time. We know that the dollar value of all stuff, nominal GDP, can be added up in any given year, but that changes for 2 reasons. So nominal GDP was equal to the sum of all prices of pizza, beer, chicken wings, weapons, and food in 2008. If we add up the prices and quantities of all the end goods in the economy, GDP, the dollar value of all final goods and services produced within the nation's boundary over the course of the year, changes for 2 reasons. Prices go up and or quantities go up. So we got 2 things moving. The thing I care about for economic welfare is the Q, the quantity of stuff. So this price level business gave us a mechanism, it was kind of a neat little trick to separate out those 2 effects, the price effect and the quantity effect. And as Jake pointed out, the price level was calculated by taking the ratio of nominal GDP divided by real GDP. In a given year. So it's an index number, and in the base year, it's equal to 100. Nominal GDP equals real GDP. So we just arbitrarily pick a year to base all of our calculations from. So the price level is a number that reflects the average level of prices a number that reflects the average level of prices compared to a base year. the price level in the base year is equal to 100. PL base equals 100. That's our starting point. So bringing this back to what we did with potential, the potential level for the economy is some amount. And that is independent of what's going on with prices. It's where we expect the economy to get to when the economy is at the full employment level of resources. Many short-term shocks to the system, like a screwed up financial market, 2008, can lead to some adjustment period going on where when a recession happens, GDP is below potential. So then we'll start getting into moving around potential. So another picture that I want you to keep firmly in your mind as we work through all of the rest of the course is the business cycle. What does real GDP look like over time? It goes through the ups and downs. So real GDP over time is the business cycle. And if we take, one way to think about potential GDP is, our belief is that the long run we kind of get to what our potential is. And so one thing we tend to do is look at the average growth of this. And so if we were to statistically fit a trend line, we seem to be kind of oscillating around an average trend. That's kind of what we're thinking, well, the potential must be somewhere there. As we go through short-run adjustments, we seem to be kind of moving around where we think we can be in the long run. And that trend line we can start to think of as potential GDP, real GDP. Why wouldn't it look like any other supply curve? So we're going to put, let me just go ahead and label this SAS, which is going to be short-run aggregate supply. I'll define it in a little bit. But when you guys looked at the supply of pizza, the supply from the weapons company in the weapons industry, the supply of food, it was upward sloping, meaning that as the price of weapons goes up, weapons manufacturers produce more. And as the supply, or as the price of food goes up, food producers produce more. More quantity supplied when prices go up. So what's going on with this picture? Why do we get this looking this way and this one potentially looking this way? Well, we held a lot of things constant when we looked at the supply of weapons. So if we've got weapons of mass destruction down here, and we are guns are us, and we see that when semi-automatic weapons are going for $3,000, weapons manufacturers want to supply 100. When weapons are going for $4,000, they want to kick it up to 150. They're willing to supply 150 weapons to the market. But we held a bunch of things constant. I try to get that ceteris paribus assumption out there. What were some of the things we held constant for this company supplying those weapons? What were some of the things that we held constant? Max?
Barriers.
What's that?
Were there barriers to entry?
That got into the market structure, but there was something to do with entry. If this is the weapons industry, one of the things we held constant was the number of companies in the industry, right? So the number of firms was one of the things we held constant. Good. Cost to produce, right? So the price of resources. And then there was technology. We didn't allow technology to change. So we held a number of things constant. I don't want to get too hung up because Taylor brought up the one that I wanted to hit on, and that is the price of resources. So as the price of weapons, this is the product price of weapons, went from $3,000 for that weapon to $4,000 a weapon, we held constant the fact that their skilled labor force, those engineers, were making a salary or a wage of, let's say, $60 an hour. So the average wage at the weapons plant, they were actually paying some engineers $100 an hour, and then they had some people that were on the line making the weapons. Let's just say on average that their wage was running about $60 a man hour on average at the plant. So when we allowed the price of weapons to climb, we held constant the price of resources. Now, if the price of resources goes up, and this stays at 4,000, so weapons goes up to 4, wages stay at 60, but now wages climb to 80, what happens to the supply of weapons? It shifts. I see some ups, downs, lefts, rights. Which direction? Oh, I didn't bring clubs today. Ah, God, I bring those things all the time, and now we got a situation where, okay, we got a modified club here. Actually, this is good with this particular diagram. What happens? Shift to the left, right? So we used to want to supply at $4,000, we'd supply 150 at wages of 60. But now at 4,000, we're going to supply something less. Maybe it drops back to here, maybe it doesn't, we don't know where. So we're going to shift the supply curve to the left when wages ramp up to 80, right? All right, so why is this important? It brings us back to one of the most important controversial topics in macroeconomics. And that is the timing of price changes. What comes first, the chicken or the egg? Do wages go up and then producers change prices? Do prices go up, then producers change wages? How long of a period of time does it take? Does it take a month? Does it take a week? Does it take a year? Probably one of the biggest issues in macroeconomics is the timing of the adjustment of resource prices and output prices. Now let me just let you think about this for a second. Let's say we're a Walmart, or we're a Country Mart, or a grocery store, or some sort of Target. What changes first? The pay to my employees, or the pay or the price of the product on my shelves as the economy moves through time? What changes first? Price on the shelves or price of wages? Price on the shelves, right? They're very reactive to that. So as product is starting to sit on the shelves and inventories grow, they have a sale. Sale today only, 20% off. Sale, and they don't say, okay, employees, we got some bad news. It looks like the economy's taking a bit of a turn. We got a bunch of inventory. I'm going to cut your pay. I know you're making $10 an hour, but today you're going to be making $9. Hopefully we'll get it back up to 10 or more tomorrow, right? It doesn't happen. So resource prices are sticky is the term we put on it. They tend to be a little sticky. They're not as flexible as output prices. And so now we've got this thing of things that are leading the curve. In fact, Wayne Angel talked about this, right? I can't remember what it was, but I just knew he talked about it. Leading indicators and lagging indicators of the business cycle. So here goes the economy trucking through time. Sometimes some variables lead the change. Some things lag the change. Leading and lagging indicators of the economy trucking through time. Does anybody remember what he said?
It was talking about the prices of commodities.
It was the commodity price, right? He believed that that was a better leading indicator of where prices were going. That's right. Yep, it was commodity prices. So he was using that as an instrument to gauge whether the economy was growing or slowing, or so it was ahead of the curve. It was a leading indicator in his mind, his opinion, that commodity price was a good leading indicator. All right, so I think we can kind of think through the process and justify that output prices and resource prices need not move in harmony together. In the long run, everything kind of works out in the end. That's why we said we can only have so much stuff. And as output prices grow, resource prices grow. So your purchasing power stays relatively constant over time at your position. So as inflation grows, the stuff on the shelves at Walmart grows in price first, and then you start realizing, you know what, my $10 pay per hour doesn't buy me as much stuff as I used to. And if my employer doesn't give me a raise, I'm going to go to another company, right? And so they start getting edged, and then the employer has market pressures. That invisible hand is saying, hey, I need to raise my wages or I'm going to lose my good employees, right? So that's that invisible hand of Adam Smith working its way through the market to try to push up those wages. So in the long run, if output prices grow by 10%, wages will tend to grow by 10%. So, and same thing with other resources, capital and land rents. So those two things eventually move in harmony, but not necessarily in the short run. So that brings us to this short run aggregate supply curve and the important distinction. In the short run, over some period of time, if we buy into this belief that resource prices lag behind output prices, that potentially gives way to a curve that looks like this. Just like it happened for the weapons manufacturer, it happens for all businesses. And so we got the same thing going on here. We're going to hold resource prices constant along this, back to the economic model, along this curve. Resource prices are going to remain fixed. So if wages on average were $10, we're going to let W represent all resource prices. I like to use W because we usually end up talking about wages. All resource prices. And now we got the same thing going on at the micro level, aggregated up into the macro economy, that there's at least potential here for us to move off of our potential long-run GDP. I haven't got the aggregate demand curve yet. That's where the change is going to happen. All right, questions or comments so far on the structure of that? All right, so let's bring people and governments and the Federal Reserve and everybody else into it. Oh, yeah, let's go throw that up. Thank you. All right. Short run aggregate supply. So short run aggregate supply shows the quantity of output supplied for the nation, or the economy, which is real GDP. I just want to highlight quantity. So it shows the quantity of output supplied for the nation at various price levels holding constant the price of resources. So we're not letting all prices change, just the prices of outputs. Holding constant the price of resources and the quantity of resources and technology. Kate, did you write down that definition of the production possibilities frontier at the
Yeah.
beginning? What did you write?
Shows the max combination of two goods and the time we can produce given its available resources and technology.
Boom. Okay, so it's the same thing that we're holding constant here, but now we're also holding constant a price. So it's tying together a little bit of that, production possibilities, adding in the price of resources being held constant. So there's a tie there. The long-run aggregate supply curve, in fact, I might want to edit this. Megan, what did you have for long-run aggregate supply? I think I just wrote it recently, but I erased it, so I can't look myself.
Shows the potential level of real GDP at full employment.
At full employment, okay. So full employment, you guys add on to your notes here a little bit. Just put full employment of the quantity of resources and technology. That's what that full employment, I put that little twist on it because that's the way we think about it more generically in macro. So full employment means use of all resources and technology at the max. Most efficient. Just kind of add that extra on, again, to tie it back to what we're looking at here. Okay, so on the demand side of the equation, let's see, I think I'll go to orange. I want you to just draw a line right through that so that all three cross in harmony there. Aggregate demand shows the quantity of output demanded. Quantity of output demanded, which is real GDP, at various price levels. Ceteris paribus. Holding all of the things constant. We're going to spend more time on the things. I'm just going to leave it a little generic for now. I do want you to add in that aggregate demand includes households, businesses, and government. When we talk about food, usually it's the households buying food from a business. And so we've got households is the demand curve, businesses are the supply curve. Now we've got everybody out there competing for those goods. Government, businesses, and households. Now, you might want to pull out, Megan had it, if you guys have that sheet, start bringing those for the next classes. I want you to just pull out this one. We can leave out the financial market one. But yeah, which it should be figure 2.7, which is that one. So the top section of the one that I gave you. We've got the all-important thing in the macro economy, cigarettes. C plus I plus G plus X. So that is the expenditure approach to measuring real GDP. It's simply saying that what flows through the goods market, the ring up here, can be compartmentalized into the stuff that households are doing, businesses are doing, and governments are doing. Households represent 70% of GDP. How much is GDP for our nation, roughly? 14 trillion, yes, 14 to 15 trillion, right in that range. About 70% of all of the income and or total spending for the nation is done by households buying stuff. 70%. That's why household spending is an important component to the macroeconomy. Then investment and government expenditure come in at about 20% each. Investment is not going to the bond market and buying bonds. We're back to real economics here of businesses buying machinery, adding on to their business, buying capital equipment. So investment takes about 20%. So that's where businesses enter the equation of GDP, buying stuff to make other stuff, buying capital equipment. That's investment. The government, buying weapons of mass destruction and other things, runs about 20% of the nation's output as well. So we've got consumption, investment, government spending, and then our last component is net exports. Now, if you were doing the math, Curtis is kind of one of our math guys, I know. I said 70%, 20, and 20. That wasn't quite making too much sense, was it? Unless X makes up the difference, and it does. It's a negative 10, roughly. And I'm using way round numbers, and these change. But that current account deficit, which is something we need to know for Chapter 10, in the United States, we export less than we import. We buy more from China than what we sell to China in chopsticks. Remember, we're a chopstick exporter, by the way, to China. I think I mentioned that before. So we sell less to the rest of the world than what we buy from the rest of the world. And that gives us that trade deficit. And that makes up some of the difference. All right. So that is all of our players in the market. And we'll leave it at that and get into more detail. I should give you one little hint here, too. The Federal Reserve, with expansionary monetary policy, starts to change household borrowing, business borrowing through those interest rates. So that's how the Federal Reserve will come into the discussion.